Hello everyone, today is day 30 of solving a LeetCode problem every day, and today let's find the maximum depth of a binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is a number of nodes along the longest path from the root node down to the furthest leaf node. So in this case, the output's going to be 3 because we have one node here, two nodes here, three nodes here. So that's a path of length 3. And we also have a path of length 3 here, which is why the output is 3. Can I scroll? Oh, scroll. Okay, seems like that's the only test case. So how are we going to solve this? I guess there's two main things we have to think about for this problem. First of all, for us to find the longest path in a tree, it's always going to be from some root to some leaf node, right? Because if we're not going to a leaf node, like for example, we go from this node to this node, we know it's not going to be the longest path because there's still more to traverse. So first of all, we got to find a way to traverse all the way to the bottom of the tree. And second of all, we have to find a way to keep track of how many nodes we've traversed so far. So I'm going to do this recursively, and let's define a function and let's call this reverse. Let's see let's pass it the root, and then if not root, then we're going to return 0. Otherwise, so basically what I'm doing here is this is going to be our base case. Which is that this node right here is just null, which means we've traversed out of the tree. So in this case, we just return 0 because we don't want to increment to the depth of the tree. Otherwise, we can just say return 1 plus self.traverse root, or hold on, this 1 plus max of self.traverse of root.left and self.traverse of root.right. I believe this is it. Let's see what's going on here. So, okay, this should be right. So the reason we're returning 1 here, or 1 plus whatever this is let's say we're starting from this very root node. We do 1 plus the max of this because we're taking into account that the beginning of the path here already adds 1, so this 3. So for example, if there was just a 3 over here with no children nodes, the length of the path would be 1, which is why we're starting out by adding 1. And then we're taking the max between basically the left and the right children. So if there's a longer path in the left subtree, then that's the value we're going to take. If there's a longer path in the right subtree, that's the value we're going to take. And you can kind of see how this is eventually going to give us our maximum depth. Because let's say we're here at 3. So we start at 1. We traverse to root.left. So if not root, return 0, but we're at 9. So now we return 1 plus the max of these two. But now we do this again. Let me find a better way to do this better way to display this actually. So let's see, we have max self-traverse. So we want the max between 1, because there's another 1 here. But then if we go to traverse root.right, we have this 20. So that's a 1 plus the max of whichever, because it's not going to matter. So it's just going to be 1 and 1. So this just becomes 1. So we have 1 plus 1, which is 2. So this becomes 2. Then we go back again. We take the max between 1 and 2, which is 2. And then 1 plus 2 is 3, which is the output. So I mean, I kind of hope that makes sense in a way, but basically the general idea is each time we traverse a layer, we add 1. And then to that, we want to add the longer path between the left and right subtrees. So that's basically what's going on here. So for this should be fine. So if the tree is also empty, we're just going to return 0 because the length of the longest path would be 0. So in this case, we can do max depth is equal to self.traverse alongside the root. Oops. And we just return max depth. Let's submit this. Cool. And that's my solution. So the time complexity of this is going to be linear. And the reason why it's linear is because we're processing each node each time. So yeah.